Alright, so number 25 on page 737, we're halfway through this. Now we need to find the perimeter. So to find the perimeter, we can simply add up all of these, so 8, 7, 7, 6, all the way around, or we can, since we have 2 of each, we can say 2 times 8 plus 2 times 7 plus 2 times 6 plus 2 times 5. And that will also give us our perimeter. So we have 16, 14, 12, and 10. So 52 centimeters for perimeter. The next problem comes from page 746. It's number 14. Find each measure, assume that segments that appear to be tangent are tangent. So we have a theorem that states when you have a tangent and a secant intersecting on the circle, then this angle will be equal to half of the intercepted arc. So we first have to figure out what this intercepted arc is, and then we'll take half of it. Well, we know that the arc on the other side is 154, and altogether they must add up to 360. So this other arc would be 360 minus 154, which is 206. So the measure of angle ABD is just half of that, or 103. On the same page we have number 20. We want to find the measure of arc JM, and I'm going to actually insert N in there, JNM, because it's a major arc, so we should have 3 letters. So I think that was just a typo. So the measure of arc JNM. We'll call that X. So to find X, we have an angle outside of the circle formed by this secant here. It's a secant intersecting at 2 points, and this tangent here intersecting at 1 point. So this angle will be equal to half of the difference of the intercepted arcs inside of that angle. So we have this angle, or this arc, from here to here, which we're calling X, and then we have this arc inside of that angle, the sides of that angle, which is 111. So to find X, we have to set up the equation from the theorem. The angle is equal to half of the difference of the intercepted arcs. So X minus 111. And solve for X. So we would multiply both sides by 2. And when we do that, 2 cancels with 1/2, and we get X minus 111 is equal to 94. So add 111 to both sides, and X is equal to 205. Next we have number 37 from page 748. The circles below are concentric, which means they have the same center. What is X? So there are 2 steps to this. We have this angle formed on the outside of both of these circles. So, and we also have these 2 lines which are secants to both circles. So we're just going to look at this inner circle first, and then we'll come back to the larger circle. So for this inner circle, our angle on the outside of the circle, so we'll say the measure of angle A is always equal to half of the difference of the intercepted arcs, or the arcs inside of this angle, here and here. So half of the difference of 118 and 54. So if we do that, we would get 64 divided by 2, or 32 degrees. So the measure of angle A is 32 degrees. Now we have enough information to solve for x, because we have the angle on the outside and we have one of the intercepted arcs, and we want to find the other intercepted arc, and now we're looking at this larger circle. So we're using the same theorem. We're setting it up so that the angle on the outside of the circle is always equal to half of the difference of the intercepted arcs, the arcs being 79 and x. So if I multiply both sides by 2, I would get 64 is equal to 79 minus x. So subtract 79 from both sides, we get negative 15 equals negative x, and therefore x is equal to positive 15. Let's take a look at number 21 from page 754. Find each variable to the nearest tenth. Assume that segments that appear to be tangent are tangent. So we can assume that this segment, which appears to be tangent, intersecting the circle in one point, is tangent. So with that said, our theorem states that whenever you have a tangent, to find that length, you square the tangent, so that would be d squared, and then you set it equal to, here we have two secant lines. So I can't use this middle one because I have another variable there, but I have this other secant, which has a total length of 15 plus 11, or 26, and the outer length, so the portion of the secant that's outside of the circle, is equal to 11. So we're going to set the tangent squared equal to the outer portion of the secant times the entire secant length, 26. So d squared is equal to 286, and from there we take the square root. So d is approximately 16.9. Now we're ready to solve for c. So to solve for c, that's part of this secant. So we want to do the same thing that we did for this secant. We want to take the outer part times the whole thing. So the outer part of this secant would be right here. Outside of the circle is 9. So we want to take the outer part times the whole thing. Now, the whole thing would be the expression of c plus 9. So we're adding those two parts together. C plus 9. And we need something to set it equal to. So we can set it equal to the parts of this other secant, just like we did in the last problem. Take the outer part times the whole thing. Which that I know is 286. And I distribute on the other side. And I subtract 81 from both sides. And I divide both sides by 9. And I get 22.8. So C is approximately 22.8. From the same page, let's take a look at number 10. Find x to the nearest tenth. Assume that segments that appear to be tangent are tangent. We don't have any tangents here. In fact, we have two secant lines. A secant here and a secant here. So whenever you have secants, take the outer part times the whole thing. The outer part times the whole thing. So the entire length up top would be 4 plus 8, or 12. The entire length of AE would be the expression 3 plus x, or x plus 3. It doesn't matter how you write that. Usually we write our variable first though. And then we're going to set those equal. So we want to set the outer part times the whole length equal to, for the other one, the outer portion times the entire length. So multiply and you get 48. Distribute and you get 3x plus 9. Subtract 9 from both sides and you get 39 is equal to 3x, and therefore x is equal to 13 if we divide both sides by 3. A piece of broken pottery found in an archaeological site is shown. QS lies on a diameter of the circle. What was the circumference of the original pottery? Round to the nearest hundredth. And this is actually from page 753. So from page 753, number 5, and this will be the last problem of the review. So we know that QS is part of the diameter. Diameter is just a chord, so if I wanted to figure out what the rest was here, I can call that portion X. Since I know that my diameter is perpendicular to this other chord, then that means it will bisect the chord. So if this is 10, then this will be 10. And then I'm going to use the theorem that states that anytime you have two intersecting chords, the product of the parts of one chord, so 10 times 10, will be equal to the product of the parts of the other chord, so 6 times X. Therefore, 6x is equal to 100, and by dividing both sides by 6, x is equal to 100 over 6. And notice I didn't get an approximation yet because I have some more calculations to do. So, what do we ultimately want to find? The circumference of the original shape. So how do we find circumference? Circumference is 2 times pi times radius, or diameter times pi. Well, do we know what our diameter is? We know that this other part is 100 over 6. That's what x is, but we have to add this part to it. So our entire diameter is 100 over 6 plus 6. So to get the circumference, we want to take that times pi. Diameter times pi. And from here, we can just type it into our calculator and get one nice approximation. So parentheses 100 divided by 6 plus 6 parentheses times pi. And that should give you approximately 71.21. 71.21 centimeters, because we're talking about the distance around the circle, the circumference. So hopefully this helps in reviewing for your test, and good luck.